Hello everyone, welcome to Algo-holic, the place where you learn not just the solutions but the thought process behind solving problems. Today we're solving the problem best time to buy and sell stock part 2. We're given an integer array prices where each value is the price of a given stock on ith day. We might decide to either buy or sell a stock and we can hold at most only one stock. We can also buy and sell the stock on the same day, which would result in a profit of zero. I don't understand why they've given that in the question. Anyways, we're supposed to find and return the maximum profit we can achieve. This is the continuation of the previous problem, so I recommend you finish that before trying to attempt this because the way we approach both the problems is pretty similar. Let's look at an example. Here we have an array. So we buy the stock on this day, we sell the stock on this day, we get a profit of 4. We again buy the stock on this day and we sell the stock on this day, we get a profit of 3. So the total profit is going to be 7. So what is the brute force solution to this problem? This is one of those problems where the brute force solution has nothing to do with the optimal solution. You cannot get to the optimal solution from the brute force solution, but I think it's still good to know. In fact, the code for the brute force solution is much harder to come up with than the code for the optimal solution too. So for the brute force solution, for every particular value, we have two actions that we can perform. We can either do something on that day or we cannot do something on that day. So on the first day, we cannot sell the stock because we still don't have the stock, so we can only buy. So buy or sell, we need to know what position we are at currently. So we also need a flag to tell us whether we currently have the stock or we don't have the stock. So initially we don't have the stock, so we can only buy or we can skip that day entirely. So if we're buying, the value is going to be 7 because that is the first value here. The second day, we can either sell at 1, which is the second value, or we can do nothing. The second day, again, we can buy at 1 because in this branch, we still don't have the stock, or we can do nothing. The next day, we can buy again at 5 or do nothing. Here, we can sell at 5 or do nothing. Here, we can sell at 5 or do nothing. Here, we can buy at 5 or do nothing. So you get the idea, right? So the depth is going to be n, and on each level we are branching it into two branches. So the time complexity is going to be 2 to the power of n. So what is the most optimal solution and how to arrive at it? The key here is to visualize the problem in a much simpler manner. So let's take another array 7, 1, 3, 5, 2, and 4. So what is the profit here? We can buy it at 1, we can sell at 5, we can buy at 2, we can sell at 4. So the profit made here is 4 in this transaction and 2 in this transaction. So the final profit is 6. Now, can you find out any pattern here? The array is divided into subarrays where each subarray is in ascending order. So what the question is really asking of us is to find out all the subarrays in the array where each subarray is in ascending order, and we're supposed to get the difference of the max and the min values in those subarrays. So let's try to solve this problem by figuring out all the ascending order subarrays in the array. So the key here is to find out if the current value is less than the next value. If it is, then it is part of the subarray. Now here 7 is not less than 1, so 7 is not part of the subarray. 1 is less than 3, so it's part of the subarray. 3 is less than 5, so this extends. Now 5 is not less than 2, so this is one subarray. Now 2 is less than 4, so this is another subarray. So the final profit is going to be 5 minus 1, which is going to be 4 here, and 4 minus 2, which is going to be 2 here. So the answer is 6. Once we code this up, it's going to become much more clear. The time complexity is going to be bigger of n because there's just one pass and we're not taking any extra space. So this is the most optimal solution. Let's quickly code up the optimal solution. Now we can either start from 0 and go up until n minus 1, or start from 1 and go up until n. So this is just a personal preference. Sorry, this is length. Now, instead of comparing the next value to the current value, we're comparing the previous value to the current value. So prices of I is more than prices of I minus 1. Here, there's a slight optimization. What we did here was we took the last value, which is 5, the first value, which is 1, and we calculated the profit this way. Instead of doing this, we can calculate the profit at every intermediate step. So when we reach 3 over here, we calculate the profit here. So that's going to be 3 minus 1, which is 2. And when we reach 5 again, we calculate the profit again, which is going to be 5 minus 3, which is going to be 2 again. In the end, we end up with the same profit, which is 4. So what we're essentially doing is we are buying at 1, we're selling at 3, and we're again buying at 3 and selling at 5. So profit is prices of I minus prices of I minus 1. That's about it. We just return the profit in the end. Yep, it works and is the most optimal solution. C++ and Java code looks pretty much the same, where we have profit initialized to 0, the loop, we're checking if the current value is more than the previous value, and incrementing of profit. Java code again looks pretty much the same. The only difference is the way we calculate the length of the prices array. So that's all for today. I hope you found this video helpful. Your feedback helps me make better content, so please share your thoughts in the comments below. I'll see you in the next one.